group out here. I'm Scott Lawrence. I'm an associate professor in the architecture program. And it's my pleasure today to introduce Rick Sommerfeld, associate professor of architecture, director of graduate studies, architect, and the director of the Colorado Design and Build, the Colorado Building Workshop, Design Build certificate at the University of Colorado, Denver. I have the pleasure of being a former student, colleague, and mentee of Rick, and I'm immensely thankful for, I figured it out, it's been a little over 20 years of incredible advice and sharing from Rick. A wealth of knowledge, not just about the sort of design build side of things, but about architecture in general. And I hope that as you're watching today's lecture, what you're taking in is an approach to architecture, an approach to how we go about seeking out and resolving a problem, dealing with the constraints as we see them, as we meet them, finding innovative ways to find, we'll call it dangerous word, but I'll say it, we'll find beauty in the ugly. And the ugly side of what we do, the dangerous side of what we do is a little bit what you'll see in some of the sites that are here, but I think that what Rick does better than really any architect is to find a way to work through the difficult constraints that would otherwise shut down a problem or shut down a project and make it not possible, and find a way to come out the other side with something that betters the space that it's built in. So with that, I'll welcome my friend and mentor, Rick Sommerfeld.
Well, thank you, Amy and Andrea, for inviting me, for Scott, for your incredible friendship through all those years, and for somewhat listening to me when you were my student. I think what's interesting about architecture school, and for a lot of us, is this idea that we really kind of come in thinking that as an architect, these amazing projects like museums or libraries, schools for children, even an opera house, can be the projects that we all sort of aspire to. But for the last 15 or so years, I've been working with students on a series of more mundane typologies, a series of affordable houses on Navajo Nation, where we're building for people sort of in need down there of affordable structures, to things like a series of small cabins for tourism in Navajo Nation, to bird banding facilities, outdoor classrooms for urban farming, a series of small cabins right along the Continental Divide, which actually Scott was one of the professors on, called the Colorado or Outward Bound cabins, to a series of community centers in Moab, Colorado. My students have worked on toilets for basically human waste in the backcountry on Longs Peak. We've done educational cabins for kids, bike shelters to start to think about how we can deal with urban infrastructure in downtown Denver, a bridge, and then more recently we just completed a series of research buildings in Antarctica and remote penguin facility, and this last year a series of incubators for the Downtown Denver Partnership. So what's common among all of these problems is that they're relatively mundane typologies, things that architecture firms wouldn't really be interested in, things like shade structures and toilets, huts, micro cabins, which when we started to do that work wasn't something that was really on anybody's radar, affordable housing, and even research stations, which really from a budget standpoint don't command the fees that most architects would achieve. But in many ways, these small mundane problems actually start to address pretty interesting societal issues that aren't necessarily all that mundane. So how do we deal with areas in urban cities that have food deserts? Or what do we do about workforce housing, and how can we make things more affordable in some of our communities? And I think even in Idaho, around your ski areas, you're dealing with things like that. What are we talking about when we look at overfishing, and how do we control kind of fishing populations, or dealing with things like forest fires? So these become a series of architectural research topics that not only faculty like myself can generate funds around, but also become these issues that students can begin to look at as well, where we think about energy use or contextually responsive design, maybe innovative ways to rethink kind of structural engineering or material reuse for affordable reasons. And in a way, I think Renzo Piano sort of says it best when he talks about the idea that, as Scott alluded to, this idea of beauty is very difficult to separate from the engineering problem. And that in many ways, when your clients begin to sort of see the logic in the design process that you put forward, and you're creating a beautiful solution, you don't have to sell it as a beautiful solution. You can actually start to think of it as a way in which your architecture meets a particular engineering goal or a design goal that has value within that client. And then you get the best of both worlds. You're able to kind of move away from architecture as a series of check marks to meet criteria that your particular maybe municipality sets up that says you have to meet these lead parameters, or you have to start to think about what is the new kind of trendy material, and look for a more integrated, holistic approach where an architectural solution can be functionally layered in such a way where it starts to address problems like the environment, material, structure, light, in an integrated kind of composite, right? Where in this particular case, just as one example, we created a series of micro cabins, and those micro cabins really started to look at the idea where the campers themselves could create agency within their own space, but also lift those buildings off of the ground so that the mice that are inhabiting that area that carry hantavirus wouldn't necessarily be able to get up into the cabins, and if they did, hang all of the bunk beds from the ceiling so that they didn't really have any place to nest. Or if we're looking at kind of the ideas of affordable housing, we can take the same kit house that's sort of illustrated here and use that same lumber package to actually create something completely different. So no more, no less, right? Perhaps innovative than the house that you sort of see here, but arguably a little bit more beautiful, and it uses the sun to kind of collect that heat to basically warm the house to eliminate some of the electrical bills. Also, in terms of the idea of bringing tourism to a particular area, we can sort of rethink what tourism looks like and how you can attract people to some of these destinations. This is down in the Four Corners near, you can see Monument Valley. So all of these sort of architectural solutions for us start with an idea that the design process really is about identifying these opportunities. And what opportunities exist within one design problem don't necessarily exist in another design problem. And it's up for the students themselves in our particular case, or you hopefully as an architect as you go out into the field, to begin to understand what that design problem is and begin to start to think about how can I identify those things. In our particular case, working on the long feet toilets, we essentially created an architecture that could blend into that environment when they asked us to sort of merely replace this mundane typology. So we were really kind of thinking about what are the opportunities that present themselves when given this piece, and they say, hey, you have about $35,000 to essentially rebuild the toilets. The marmots are chewing on the wood. What can you do to take from the trailhead at 9,000 feet, the campsite where we actually stayed at 10,000 feet, to these three locations to control human waste in the backcountry? How can you get those in with helicopters and begin to blend them into the environment? So for us, that research component, which I think a lot of you guys are working with in the beginning parts of your studio, become an incredibly important part to work through this design problem and start to see all of the potential kind of constraints of a problem. What are the things that we know that we have to deal with, and what are the opportunities within that exist, so that when we present to the client, we first, instead of presenting the actual aesthetic or design solutions, present back through an executive summary a series of historical data components, maybe ideas about program, starting to think about what some of those constraints are, and then presenting back ideas of context environment to identify what these critical issues are so that we can be in an agreement about that verbally before we start to execute the architecture. So then as we start to look at structural design solutions, we also have these opportunities that we can present to our structural engineer. That engineer can kind of give us feedback about iterations that we can start to do, and a reference to architectural concepts that we like from other architects that may not be that same design solution. In this particular case, Neil McLaughlin, who won the Sterling Prize this last year, talks about this as a conversation through time. So as we were looking at the Longs Peak project, and we identified that things like rocks were abundant in that particular environment, we looked at projects from Herzog and de Meuron, RCR, architects, that started to leverage the idea of how rocks could be collected and utilized within this architecture. We can then talk to our structural engineer about those opportunities that these abundant materials like rocks can actually be utilized and collected on site if integrated into a structural solution. And that engineer then brings ideas to the table, like articles that he or she has written or read or talked to their colleagues about. And we can start to agree on architectural approaches. In this particular case, the Serpentine Pavilion by Toyo Ito was a big component of that, to help start to think about what that architectural solution might be. So in this particular case, what we're looking at is a laterally stable steel frame that transfers the loads across the walls and then through the roof diaphragm and down the other side, making something that's inherently fairly thin much wider. And if we transfer that idea to our own project and start to think about how those steel fins form a wall and then are actually shifted off axis to triangulate the loads, even in this particular case abstractly around this ring frame, we were able to create a series of architectural walls, which we're calling laterally stable Gabion walls, in a way where we can now kind of control those lines and control the architecture through the way that those steel fins operate, learning from people like Herzog and de Meuron and RCR architects and Toyo Ito to make our own architecture, which in this particular case takes the idea of these steel moment frames, and what we've actually done is kind of created a moment frame with one leg of the moment on one side of the building and one leg of the moment on the other side of the building, and transferred that around that ring so that we can stabilize these structures. Then we have the ability to start to align those to door openings, to window openings, to the placement of the chute for the waste. That then aligns to the outside, where we're taking the structure, we're taking the material, we're taking the program, and we're starting to take the view corridors and align those view corridors to specific things like entry or the view to a particular rock formation, so that it all sort of integrates into this solution where the rocks stabilize the steel, because the steel is hyper thin, and the sort of thin steel stabilizes the rock, so we don't have to have a 2-foot wide Gabion wall. And then the engineer is giving us solutions where we ourselves as architects can go in and play with the porosity of how full those need to be on each side so that it doesn't tip over in 210-mile-an-hour winds. And then begin to start to look at the prefabrication of those components so that they can actually be separated out so that the helicopter can actually take them to the mountain and we don't have to hike them up. We built this at full scale. Mock-ups are a big part of our design process to sort of test things, both in cardboard and then in steel, in section, then starting to look at the sort of full fabrication in the shop down in Denver. And these were actually fully built in Colorado over the course of about a month and then taken apart. We used the floor, which was the leveling device, to actually pack it into helicopter pallets. And then we took that all the way up to Rocky Mountain National Park, and using a K-Max firefighting helicopter, we actually flew that material up to the job site. We hiked up with llamas and mules to bring our food and our supplies up. And then every morning, we would wake up at about 3 o'clock in the morning and hike to the job site to put it all back together. So in this particular case, we put the floor on the first day, and the second day, after the epoxy had cured, because we're anchoring into rocks, we were able to erect the last sort of 4 walls in just a couple of hours. and then went about over the course of the next 4 to 5 days collecting rock and putting that rock into the avian cages. So really this project was interesting not only because the design build process happened, I think, in a collaborative manner where we were able to come up with really interesting architectural solutions, but also that the design problem didn't stop and we weren't afraid to iterate. So here we were able to fill the avian cages really, really quickly, but we didn't really like the way that the rock looked. But in the end, what we were able to do is take all of that out and start fitting the rocks together a little bit nicer. And that gave us some patterning where I feel like the project actually blends into the environment a little bit more. So that idea of iteration, I think, becomes important in testing. We even went so far as to measure the marmot skulls, which were the little marmots that were eating the wood on the outside and then falling into the toilets, which was pretty gross. And tourists would kind of come in and be like, there's a marmot in the bottom of the toilet. So we actually went through measuring the sort of skull size to make sure that they couldn't crawl through. And then the marmots just scaled over the top and then jumped back down into here. But thankfully the new toilet technology is such that you can't actually get into the toilet anymore because it's a conveyor belt system. So the marmots were outsmarted us, but then we ultimately survived. So final project, design to kind of final construction, took about 19 weeks. And we had to think about everything from even auto-closing doors so that the wind wouldn't blow them kind of off of their hinges and how that would lock. They're ADA accessible because they had to be. Anything that's built in the park actually has to be accessible, which was an interesting design constraint to have when you're 12,800 feet above sea level. And then each one of these little windows names a particular view. There's all the hard work to make sure that the marmot didn't get in, and they just scaled right over the top. Another project on the Front Range that we worked on is the Auraria Bike Pavilions. And again, this is an interesting lesson in collaboration and starting to think about the design problem and what we thought was important. In this particular case, things like material and structure maybe were downplayed a little bit, and context and program were played up. The clients had about $100,000 to build this. They said, we have $100,000, this is the proposal that we have. If we give you the $100,000, do you think you could do something different with it? So they had 2 locations that are along the 5280 bike route, and one of those locations is one of the top 5 places in Denver for bike theft. The existing sites weren't particularly nice or interesting. There was an old sort of asphalt space right in front of this Helmut Jahn library. He was a famous architect in Chicago. And then the other one was built into the hillside because that's all they really wanted to give us. So the students went about sort of thinking about the idea of a bike and bike parking and how bikes could theoretically park in a similar space, and what if we started to think about the idea of extruding spaces. They wanted the bikes to actually have enough transparency that you'd feel safe being in that sort of bike space, but they also wanted to be opaque enough that it wasn't like all the bikes were visible in the context and it just looked like a cage with a bunch of bikes in it. So they started to suggest this idea of a vertical louver, and those louvers reference the library, and how those louvers might be oriented so that safety through environmental design principles could be utilized, so that if you're at one of the 2 corners, you can actually sort of see into the bike shelter, whether that's somebody who's in there at night alone, you could see into it for their safety. Whether it was the idea that someone broke into the bike shelter somehow and was trying to steal a bike, you could see into it. But also that there was opacity as you're walking down the street in reference to that louver so that it fit in a little bit more. So the students started to look at the idea of how entryway and circulation would work, incorporating the sort of surrounding architecture, and then lines of sight through the space so that there's actually an alignment from one side to the other, which creates a series of kind of transparent spaces. They also started to look at alignments where this edge holds with the library and kind of reaches out to the context. And some of these louvers could actually be used for more than just bike parking. How could it be the place for gutters and downspouts and water, for signage? How could the bike piece become a symbol for the actual symbol of a bike as well, or the electrical panel? And so they went about kind of designing and fabricating this space where even the idea of the poetry of the light and the shadows started to cast on the ground and create these kind of parking spaces. So in 2 locations, we built 2 bike shelters, mostly out of limestone, and that limestone was something that we looked at through materiality, a cross-laminated timber roof, and then we looked at minimizing the carbon footprint of the concrete by starting to adjust the way in which the foundation was done. So this is a software that Kieran Timberlake developed, and the students used this as an iterative tool to kind of make design changes. Ultimately, the bike shelter collects its own water and then harvests that water into landscaping, uses a series of sort of limestone louvers that reference the surrounding context so that you can see whether there's spaces available, and then ultimately uses this larger cross-laminated timber roof to make the span and make the building fairly sort of small. So in both of these situations, the louver adjusts based on the context. One is basically referencing a church and its sort of scale of limestone, and the other one, AC1, which is our main classroom space. So you can sort of see how the shadows come in and start to make those bike spaces. At night, how you can start to see how that parking actually is utilized and not utilized. And then that idea of the louver itself and the development of that particular idea and its numerous iterations. So for us, we looked at sort of the idea of white brick and red brick. We looked at this idea of limestone, how that limestone would click back to that steel louver, how that steel louver could be structural, so we don't actually have any shear walls in this. Those are all through the columns. In this particular case, COVID hit, and unfortunately the students had to kind of work in their houses, but we sort of persevered through that, making cardboard mock-ups, and eventually got back out there in 105-degree heat and put together a sort of set of drawings. The project is about design for disassembly as well, so we're starting to think about the idea that if this project ever does have to come apart, how could we as architects become stonemasons, and how could we start to look at a way to dry stack this, that this limestone could be recycled after the fact. So it's all a steel pin connection, so it's all dry stacked limestone that's pinned back to the steel structure. So each block is slightly different, but we're preserving the outside 4 faces and only making modifications to the top surfaces. So if these are ever having to be sort of taken apart, you can simply sort of unstack them. Or if repair needs to happen, those pins are just being drilled through those front faces. We also sort of folded the mesh over so that from a vandalism standpoint, people couldn't kind of get in, and then started to test that, starting to think about how the louver could even start to collect water. And again, making mistakes, right? As this test is going on, that water is actually not moving down the backside, it's skipping everything. So we had to look at new ways to make modifications in the field through what I think is really great about design build, that testing and iteration. So the students went about sort of putting that whole thing together, and here's some imagery. You can start to see how they plasma CNC cut the bike logo and back LED lit it. You can start to see where those rain gutters are kind of coming down, how they're cutting into that asphalt and reusing some of the materials like those stone louvers as part of the landscaping, and then how we cut into the hillside to retain that earth and bring people sort of into the space. So some of the finished photos. We even did skateboard racks. Okay. Next project was really about this idea of workforce housing, and one of the things that we were starting to think about with workforce housing in the Colorado Outward Bound School was how do you retain staff that are sort of the seasonal staff. And the Outward Bound School came to us and said, we have about $5,000 per unit. We'd like to buy these from Home Depot and have your students come in and actually put bunk beds in them so that we can have workforce housing. And we basically said, and Scott was a part of this design build project, why don't you just give us the money and we'll figure out how to do something better. So we interviewed those clients. We started to look at the existing housing conditions, which is a Toyota Tacoma. That's what they were doing instead of actually living in the dorm rooms. And what was important to these individuals, which was mostly their gear, that they actually had more money invested in their gear than in the stock market or in their own vehicles. So we conceived of a project that actually not only created a house for their little cabin, but a sort of super roof that created shading so that they could actually house their gear underneath this and keep their skis, keep their bikes and other things safe. This project was 21 micro cabins over 2 years, and we decided to do the first 14 micro cabins in the first 19 weeks, requiring each student group of 4 to build 2 cabins in about 4 weeks of on-site time. So it was a pretty ambitious project, and it was one that we had to do a lot of prefabrication on. So you can sort of see the housing layout for the 21 cabins. The first round of cabins sort of happened here, which was the junior staff portion of it. And the students actually built a full-scale mock-up inside the architecture school to just sort of test their ideas before we went into full fabrication. But each one of the 14 cabins is unique to its own condition and its own site, leveraging ideas of views down or individual versus kind of communal living, depending on the parameters that those clients wanted. Some of them really looked at the idea of outdoor porches or shared spaces so that the community could kind of gather on multiple porches and hang out together. Others started to look at sort of larger bays where people could even park a car or hang a hammock. And each student kind of authored this in their own sort of way based on what their site was telling them. So each of the 14 cabins, like I said, is a different sort of floor plan. And they all sort of sit sometimes on rocks and sometimes on a series of concrete piers. But the steel frame was something that we were able to kind of mass produce in Denver for the most part ahead of time, and then prefabricate the walls and slide those units in. We also CNC'd all the interiors so that they went together a little bit faster. And you can see students even went so far as to frame individual trees. Some of these interiors sort of fold out so that they can be beds, but also be more kind of open when they're not living there or they're not sleeping. And started to work on kind of custom details about structurally insulated glazing that reflected that environment and tried to blend into the surrounding lodgepole lines. The students created hybridity within some of these interiors where it could operate as both a little window seat but also was the same height as a desk. And also created outdoor spaces like little bars or ventilation portals where people could actually get some cross ventilation. But it was really about trying to blur the boundary between inside and out and living inside this small birch wood interior where the glazing kind of comes down all the way to a zero edge frame so that that line between inside and out is blurred. And then the second year, we actually went in and created a structure that was a little bit more intimate, and we fired the faculty member that was with us the first year, who was always laying down on the job. Right? So, he came here to Idaho, which was great. And continued the project. Without him, we were only able to do 7 cabins instead of 14. So we took our foot off the pedal a little bit. But these cabins were highly insulated. They captured their own flat roofs, captured the snow, which has an R value of about 1 per inch. And that gives us the ability to increase the insulative value of the overall assembly by about R36 in the winter when you need the insulation the most. It also creates a sort of intimacy where these are senior housing, staff housing. So that gives them essentially the ability to be a little bit quieter and a little bit more insulated. They become a little bit warmer. And hopefully in terms of staff retention, if you were in one of the cabins from the first year, when you first started at Outward Bound School, you knew that if you stayed on for a year or two, you might get upgraded to one of the nicer sort of staff housing. And they've seen a huge increase in their staff retention since they've had these. So we think it's relatively successful based on how we were able to create a pretty, I think, interesting model for staff housing in their organization that allows them to kind of see their staff coming back. Within that 200 square feet, there's actually 2 cabins that are separate. These are even more micro. but they all have their own front porch, they have their own outdoor space. They start to look at ideas about, bar grade floors, so you can knock mud off of your shoes, and slatting to create privacy. They take on some of the same ideas about this zero frame structural glass so that it feels like you're outside even when you're inside. And the original contract was for actually 20 cabins, but the director liked the project so much that he personally financed his own cabins so the director of the Outward Bound School could actually have a place that he could go. And he auctions this off at the Black Tie event every year, and it goes for like $2,000 a night, which is pretty cool. Okay. And then the last project that I think I'll show tonight is the Holt Waters Field Camp in Antarctica, which is a 2-year project looking at the idea of a relatively, again, mundane typology in Antarctica, which is the field camp. And this field camp, fundamentally sort of misunderstands the climate of a fairly remote field location and what it means to be in a place where you actually have this much of a marine climate, both in terms of snow and wetness. The Antarctic kind of continent is 90. See this small little peninsula. That peninsula houses the research station called the Holt Waters Field Camp. There's also a Chilean base, but you can see the glacier and that glacial formation. This is the only area on that tip of the island that doesn't have glaciers, and that creates a very, I think, fertile habitat for a lot of the wildlife and the animals. So this facility is owned by NOAA Fisheries and their Antarctic Eco Research Division. They're essentially studying krill migration patterns in the Drake Passage, which I think is a pretty interesting kind of design prompt in and of itself, right? It's like, how do you start to study something this small and understand whether we're overfishing it? And one of the best ways to kind of begin to understand that prompt is through the predators that actually prey on that, which is mostly whales, and then also Antarctic fur seals, which are a big kind of nesting habitat for that group of animals, is on Livingston Island because it's so close to the Drake Passage where a lot of those krill are actually moving through. And then the leopard seals, which actually prey on both penguins and the fur seals, mainly the fur seal pups. Elephant seals, which are the grossest animals on Earth. And 2 sort of species of penguins, the chinstrap penguin and the gentoo penguin. There's about 30,000 nesting pairs on the island. And those sort of 2 penguin populations group together in these giant colonies. And you can see that the red, right, probably not hard to guess, is the pink from the krill. So that's pretty much their excrement. So the second grossest animals on Earth, as cute as they are penguins. They smell awful, and they live in these giant colonies just basically full of krill. And then skuas, which is another predatory species. These birds actually feed on the penguin chicks. So these scientists are collecting data. They're doing colony sort of investigations where they're starting to see how many nesting pairs are there. And then they're collecting data like telemetry information. So they're temporarily gluing tracking devices and video cameras and then marking rocks so they know which one they glued to the back to begin to capture footage like this, some of which has created these massive data sets that we don't even really know what they're going to use. But this is the footage from that red camera of penguin actually fishing for krill. So you can see their head kind of bobbing up every once in a while and then sort of moving through these giant krill swarms. They're also using drone technology to be less invasive these days. So this is drone footage where instead of having to actually tranquilize a particular seal, they're able to sort of fly and measure using that sort of data. But their existing field camp, which was in operation for about 25 years, unfortunately was so inundated with snow and water and moisture and really didn't understand its climate that it was becoming sort of overcrowded, and it was also becoming full of mold and rot. So the scientists every year, when they would show up, would actually have to put on masks. They'd have to go in, see what that last year had sort of brought in terms of mold, because they're really only there for about 4 months out of the year. And any mold that had collected over the course of the 7 months or 8 months that they weren't there, they would have to go in and kind of peel out. So this is their vapor barrier, and the vapor barrier is actually, with the propane heat, collecting so much water that it's actually cooling on their floor. So to pull this off as a project, we've partnered with Bespoke Project Solutions, and Shaggy Niehausen and his wife Jamie own Bespoke. They were both Antarctic contractors who worked on things like Palmer Station, McMurdo. They did the last $40 million of the South Pole Station. Because the timeline was relatively aggressive, we still are operating within that 19 weeks from a student sort of standpoint. So we had to design, build, construct, and then deconstruct, pack, and get everything shipped in about 19 weeks. So we essentially have the research, design, and testing kind of happening in that fall, and then all of that prefabrication happening to take it down to Antarctica. And then we had a new student group that came in, and we did that all again. So the students looked at kind of program efficiency, heating and cooling. They had to start to think about a storage analysis and generally analyze how much storage was in their old camp and how much storage we basically could put in the new camp, so that from a metric standpoint, we increased their productivity with the same footprint. So we weren't allowed to build any more field camp than was there, but we were able to move some of the things that were the decks in sort of side so that the overall footprint remained the same, but we were able to gain a little bit of square footage. But we also wanted to look at how inefficient they were and how efficient we could be with the new sort of piece. We also wanted to study things like daylighting analysis and glare to ensure that when the scientists were actually doing some of this work, not only was the interior not full of moisture and humidity, but from a daylighting level standpoint, when they were actually practicing, they had an opportunity to work in the sort of healthiest conditions possible. So the students came up with those sort of designs and renderings and ultimately came to a floor plan where we designed and built these two buildings the first year, and then this building, and in the later image, you're actually going to sort of see this penguin blind the second year. So the first building has to essentially deal with their communication area, their dining, their kitchen, a mud room to basically allow them to take off all of their clothes that have all the scientific grit and poop and urine and all sorts of nasty stuff on it before they enter. And it also had to have enough food storage so that they could live for about 3 months. You're about 2 to 3 days away from being rescued if anything happens. So they need food to basically last them that long, and they were separating the buildings mostly for purposes of fire. So if you burn down one building, hopefully the other buildings are still there. Which is also why there's an emergency sort of penguin lab about a mile away, that if the whole campus burns down, they can actually run out to the other place and call from their comms tower out there to get rescued. The other piece that we really had to look at was this idea of the bunkhouse and how scientists live in the field. One of the things that's really interesting is that these scientists are a variety of sort of different ages, and from a privacy standpoint, you don't have necessarily a shower. I mean, we say that there's a shower here, but that shower is basically 5 gallons of water that was collected from the roof, heated up on the stove, and then pumped on top of you once a week. So it's a very fast shower, and it's generally a very cold shower. So you're changing your clothes not very often, but when you do, we wanted to kind of create these nodes of privacy and areas where people could sort of escape in the bunkhouse. So we've created a more sort of social space where some of the science work can happen, but also these sort of nooks of bunk beds, because in their earlier bunkhouse, the bunk beds were right off the kitchen. So if you're changing your long underwear, or if someone comes in and makes a cup of coffee, right, you're essentially doing that in front of all of the other scientists. And then finally, we wanted to create a fur seal lab and science space, a shower, bathrooms, and a workshop so that they could maintain their property out there. And then this remote penguin lab, which they call the worse than mud room, the mud room, and then the actual like science space. When you're trying to put a tracker on the back of a penguin, you're holding that penguin under one arm while the other scientist is putting that tracking device. Penguins eject their feces like stepping on a tube of toothpaste out of the back of themselves like a jet stream. So when they get nervous and you're holding on to them, it's basically like a water cannon being fired at you at all times. So when these scientists come out of the field, they have these outer bibs that are just covered and they smell so bad. The poor two, they call themselves the pennivistas and the penguinistas. And the penguinistas were these two women who didn't even know that they would smell bad, and they would come into a room and everyone was like, oh my God, you guys. Right? So we actually have a whole lab here, mud room, where you can take that first layer off, and then it smells so bad that you walk across the entry deck, and then you take off your puffy jacket and everything else, and then you can actually be in the sort of science space. So the students sort of conceived of this series of buildings as something that when you arrived at the field camp would stand up and off against the horizon, this white sort of snow field that you would sort of see when you arrive would have a dark kind of building on the horizon. And then as that snow melted, it would blend in so that during the field season, from their renderings, you would actually start to feel like the camp was a little bit more invisible. This project is like a solar decathlon, you know what that is, where the building basically has to collect its own water, it has to collect its own power through wind generation and photovoltaics. The water's being collected through this twisted gable roof and captured in these rain barrels. It operates completely off-grid. The bathrooms are a very sort of rudimentary sort of system out there. The shower, as I mentioned, is also pretty basic. And then they have this sort of comms tower that allows you to call back home on a satellite phone. But the students basically went about started to studying this at one-to-one scale through kind of mock-ups. They looked at materials that were marine-grade materials, things like blue pond plywood, which is Meranti, used in Italian boat building. They looked at things like concrete countertops and stainless steel, in this particular case, a light interfering color stainless steel that blends into the environment so that it's completely maintenance-free and the scientists don't have to worry about anything. They stained it with an Odie's oil, which is a low VOC, no VOC oil that can be maintained as well. And then similarly to our other projects, we started to test the idea of these mock-ups, lightweight panels, so that it could all be prefabricated. The one thing that we really understood is that all of this material had to break down into a size that could fit on a boat because, oh, by the way, you can't have any machinery in Antarctica on that particular island. So we only had 10 people that were going to Antarctica as part of that construction crew, and we had to understand how all of this could be loaded onto Zodiacs off the side of a ship and taken load by load by load to the shore, where it was then taken by Zodiac to the job site. So this prefabrication was completely done by the students. They built this in Denver, as you can see. This is where the Avalanche and the Nuggets play. Down to at every sort of last fastener and screw, every piece of cladding, every window mullion. And we even started to sort of look at how the beds could be displayed. And then we showed it to the scientists because they hadn't actually sort of seen it before. So you can imagine their sort of surprise in seeing the final sort of product that they would be living in down there since they've been living and cleaning, you know, in mold. And then we actually had to deconstruct the entire project, pack it into a series of shipping containers, take those sort of shipping containers down to Long Beach. From Long Beach, it got loaded onto an Antarctic research vessel and out onto the Drake Passage. We started that process, and then we had to unload it all because the seas were so bad that the swells were 60-foot swells, 30-foot waves. So I don't know if you can visualize what a 60-foot wave would look like, but they're like, we can't cross. So when it was okay to cross the Drake Passage, we crossed when the waves were 4 meters high and the swells were about 12 feet, and the pitch on the horizon was about a 30-degree pitch from that piece. So I've never been seasick before. I was seasick. Once that was done, we actually had to unload this piece by piece by piece over the edge and then into a Zodiac. So you can imagine that as the boat's moving one way, the load's moving another way, and you're dropping that down into a boat over the edge, sometimes smacking that against the hull of a boat over and over and over. We did this about over 500 times and took it to shore. From the shore, we actually had to sort of hand offload that. So we're bringing it basically by the Zodiac load, and you can see the other Zodiacs going back to do another load. And once we land on that island, there's a receiving crew there that's then hand offloading that, where we had to stage that material. So you can imagine the pressure on the students to begin to kind of understand that each piece had to be accounted for and tagged, and then staged on that sort of shoreline. And then from there, we have to actually take it by sort of ATV up to the job site. But it was a fairly rocky job site, and we capsized the boat going to the bird blind, so they made us drop everything off here. So it was a fairly short haul up to the camp. Unfortunately, the other way was over 1.5 miles, and we ended up breaking the trailer and axle probably half a dozen times, picking up those pieces, and then putting that whole thing back together. But eventually, we got all the materials up to the job site. For those of you who are curious, we lived in tents the entire time that we were there. Sometimes those conditions were a little bit better than others. We worked in the rain, we worked in the cold, we worked in the mud. You kind of dry out your clothes between meals and then put the wet clothes back on. But we got a lot of really cool visitors while we were there, which was nice. This is Walter. You've never been so terrified as to hear something snoring outside of your tent in the middle of the night and not knowing what it was. But Walter was sleeping outside my tent, of all tents, and I woke up in the morning very happy to realize that it was just a small Antarctic fur seal and not something like an elephant seal that also crept into camp and did not care one bit what we were building, just hanging out. We had penguins sort of on a daily basis visiting us, and you can sort of see from some of the footage here as we're kind of erecting things, all the different colonies. So there's colonies here, 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 and the skuas that are flying around hunting the baby penguins. So they're nesting on top of their little babies as we're doing the construction in the background. And ultimately, we're able to kind of reassemble both of the buildings. In this particular case, it took about 2 weeks to get this back up. And then another 2 weeks after that to get the windows in. Again, nothing scarier than putting the one piece of glass with no replacement in, hoping that it doesn't break. The cladding and siding sort of back on. Especially in this constant wind, it was almost always at least 15 to 20 miles an hour, and sometimes as many as 30 and 35 mile an hour winds. But ultimately, we were able to kind of put the whole project sort of back together in Antarctica. And then the final product the first year was these two buildings, which this is that birthing facility where you can sort of see the beds are. This is the dining facility. And you can see the offset gabled roofs and the water. This is the camp that we disassembled the second year. And then the second year, we built the remote penguin bird blind that's in the middle of the penguin colonies. We had a couple of icebergs that sort of slipped into the bay, which was really beautiful that year. And the varying kind of conditions of it. We mostly took pictures when it was nice out, but it was almost more often than not this kind of snow. And then the interiors of those spaces where they can kind of look out now with binoculars and see those colored rocks versus having to stand out in the cold to sort of see them. Their old facility.
Someone passed me a speech.
This is the. Should turn the volume up. This is the two penguinistas. but they used to actually have to stand next to the windows with a squeegee because there was so much moisture that they would squeegee it off and look out, and then the propane heat would actually create the condensation, and then they would squeegee it off again. And they'd take a syringe and like take the water out of the windowsill and dump it outside. And then the second year, we also sort of built this second building, which was the lab itself. And the lab basically has a series of louvers on it so that you can open it up and allow the wind to come through and wind scour all of the snow so they don't have to do that much snow clearing. And then some of the interior shots that you guys have already seen of the prefab or it being down in Antarctica. It's a little blown out there. Some pretty incredible views. And then the first SEAL lab where they can fix their drones and do some of their work around microscopes and also looking out to the bay. This is their anesthesia machine, the sink for actually the krill samples, and then some of the details of just how that LIC cladding becomes really easy to maintain so that they can take things on and off, and the concrete kind of countertop finish, and then the gutters and downspouts that actually kind of collect that water. So we finished this project in February of this year, February 2024, and the photo it takes just kind of the last thing we see kind of going on here. So that I think is a pretty good sort of testament to being able to kind of create an architecture that operates almost entirely off-grid and collects its own water, and hopefully is a place for these scientists to be able to do the really important work that they're doing from now for the next 25, 30 years. So, thank you.
We have time for questions. If anybody in the audience here in the room or on Zoom.
Yeah, you talked a lot about this like very fine engineering, like creating this hyper-functional places, like your design process. I'm curious how you consider aesthetics along with that. Like, you know, like, talk about that. Like,
Yeah.
Like you're creating these beautiful objects,
Sure.
functional things, but I don't know. Like, is there ever a point where you're like, that doesn't work here?
Always.
Okay.
Yeah. I mean, I think the hyperfunctional is a way for us to kind of get to the aesthetics. For me, the aesthetics is a more, personal sort of search, and sometimes it's hard, and it's class to class and function to function, but obviously one of the things that probably guides us more than anything aesthetically is trying to make architecture that is something that works with the landscape that we're a part of and tries to balance both the materiality and to some degree maybe invisibility or a beauty where we're trying to not necessarily stand out against the landscape, but integrate within it. So I think those are the sort of aesthetic conversations that dominate maybe some of the exterior design problems. From the interior standpoint, I think utilizing the idea of natural materials is always a big thing for us, things that are highly recyclable, things like concrete, steel, and wood, which we would sort of consider materials, not products. We have a tendency to sort of really have students work with materials versus working with products. And that we're making interior experiences that both create sort of social dynamics within the space so that those users can be comfortable. And then also trying to create experiences where, and I didn't really talk about it in the Antarctica project, but the reason for that really big window is that they don't watch TV. They watch what they call SEAL TV, which is they're looking out in that dining room through those windows at the landscape, at the seals, at the penguins, and for them that's, I think, a really sort of big part of it. So you see that in now bound cabins, you see that in the toilets, even to the level of some of the people saying that it's uncomfortable to use the restrooms on Long's Peak, because if you can see out to these beautiful views, theoretically some people can kind of see back in, but we wanted to kind of create those connections to the environment that we think are important. Yeah. Sure.
So we have somebody on Zoom who has, just so they can hear, has complimented and said nice presentation, and then what's next?
Well, I mean, there's a series of projects that we're always working on, and I think no one knows this more than anybody doing design build. Like, Scott and I talk about that probably more than the architecture sometimes, is like, how are you dealing with this logistical constraint? constraint, or this money problem. So we're working on a bird banding facility and educational classroom in Colorado. We've got a couple of remote cabins right next to a forestry tower that's pretty famous that we're looking at doing for rentals. We have another project in Antarctica called Copacabana, of all things, which is their penguin research facility. This one houses about 6 scientists. That one only houses 2, so that's like a 1-year project. And then we're also looking at going back to some of our older clients, the Cottonwood Gulch cabins, which was the one that I showed with the agency, where the kids kind of get to move their sleeping bag around a little bit more. So we're constantly, like any architecture firm, trying to find 2 or 3 projects that we can get on the hook, just because sometimes projects fall through, or you go to building departments and you find out that it's not feasible this year, or there's a special use permit that you have to do. So in many ways, much like a normal architecture firm, we're looking at lots of things, but we tend to sort of privilege things that are in hard to reach locations that are hard to get at.
Way in the back.
How did you heat, insulate, and dehumidify the research station?
Great question. Yeah, we use the structurally insulated panels, which are highly insulative, no sort of wood stud framed sandwich panel that essentially has a relatively high R value and almost no thermal breaks. Then we actually utilized a HRV, a heat recovery ventilator with an inline electrical heating system. And we have backup electrical wall heaters that basically circulate the air, and the HRV dehumidifies that air through the circulation of basically heat and cooling through that. So we have 2 HRVs in the main birthing space, or in the main dining space, and then 1 HRV in the birthing space. And then, is that it? That's what you got, right?
Yeah, dehumidification.
And then, yeah, the skin is actually all Vapro Shield, which is this really high-end building wrap. And then the stainless steel skin. We used a 3/16" marine grade stainless steel, which is a higher grade stainless steel than what you would sort of see from the normal stainless steel. It's rated to be within 12 miles of the ocean, and we're 300 feet from the ocean. So we hope that that stainless steel will be a fairly maintenance-free cladding. And as I mentioned on the inside, to control the humidity and make sure that there wasn't minimizing mold, we used a Lupon or a Meranti plywood, which is used in an Italian boat building. If you see the beautiful wood boats on Lake Como, it's kind of the same wood that they actually use for those wooden boats, with a Odie's oil finish to try and ensure that moisture, if it did reach it, would minimize the ability for that to mold. Oh, we green treated the SIP panels as well beforehand, so there's a spray that you can use on those to reduce the possibility of mold growth.
How do you know where to look for like these materials?
Great question. Like, we look through these materials just through that research process, right? So we talked to a lot of consultants. We probably had about 16 consultants that the students were involved with in the Antarctica build, from forensic architects to lighting and mechanical designers, structural engineers. We looked at facade designers. We have consultants that are involved and work in the waterproofing industry. So we're bringing those people in constantly, and sometimes they have products that they're educating you on. The other sort of thing is just past experience, right? Being able to kind of reach out to people who've worked in Antarctica or having past experience with projects that operated in similar kind of marine climates, I think is a great place to start. But it's certainly not something that any architect just invents. Like, you have to begin to understand failure and understand why things sort of failed from researching projects, and then work really, really hard with the industry partners to try and make sure that you're minimizing the possibility that those same failures would kind of reproduce themselves.
Okay, we have time maybe for one more here. I saw your hand up.
How did you guys deal with like code or like break cards to make sure they were up to a certain standard that they're already set one or standard that they have like say standards?
Great question. I mean, it depends on the client, right? And the municipality that you're working in. So with Antarctica, we actually are working with CAMLAR and a whole series of governments from around the world, and there's permits that sort of exist, and so they have to sort of suggest that, hey, this base is something that we're going to deconstruct, we're going to take it completely off the island, and if so, can we build it back one-to-one? And so for that particular project, once we agreed with the rest of the countries in the world that it was okay to sort of do that, then we were under our own, I think, scrutiny to ensure that from a permitting standpoint and from a code standpoint, we were trying to mirror those codes and do that work without any building official obviously being able to ever kind of come down. And things like Rocky Mountain National Park for the toilets, the National Park Service was sort of the individuals that were permitting it, and then something like when Scott worked with us on the Outward Bound cabins, we actually had a series of inspections, and those inspectors sort of came out. So in each one of our projects, it differs a little bit, and even in terms of getting the clients, it varies. What was interesting about the Antarctica project was that they had actually seen our work online, so they cold called us and said, we see that you do work in remote kind of areas, would you be interested in working in Antarctica? And that was never something that I ever would have expected to get a phone call like that, or to be in a place where we've done enough work that people are actually starting to know about it. So I think for all of you guys thinking about like what work you do, Scott and I's mentor, Glenn Murphy, used to always say, every compromise you willingly make represents the quality of your next client, right? And I think in some ways, the idea of how you build a practice or how you think about building a portfolio of your work and what you showcase in your portfolio to a future employer, how hard you work in studio, how and where you go get your first internship, what that internship turns into, or how you start your practice, is in and of itself a portfolio. And that you all, in some ways, like get to make those decisions about how you curate and showcase and what you show. But I'll tell you through personal experience that the work that we've done when it's good work has actually gotten us more clients. And I think the harder we work and the more we scrutinize ourselves, the more that's actually given us the freedom to do some of the work that we're doing, along with seeing, I think, the interesting possibilities in these mundane typologies. Because if you would have asked me what those students thought when I presented the toilet project to them, they were all like, I can't believe we have to do this. This is a crappy problem. I don't want to do it at all. And now it's one of the ones that everybody knows, and they all are completely like forgotten about that, right? When you're talking like, oh, I knew that was going to be a cool project from the very beginning, right? Not true. So, what the project is really what you make of it, and how much work you put into sort of studying and iterating it is really kind of what you probably get out of it.
Okay. Well,
all right.
yes, thank you very much.
Yeah, thank you.